Hi and Assalamualaikum. I am Nurishira binti Ibrahim. Today, we will present about experiment 5, that is bending moment. Our member group are Abdul Aziz bin Mahdi, Haris Imran bin Hairul Isham, Zakaria Muhammad Ismail, and Nurul Shahira binti Ibrahim. So we go for objective. The objective of the experiment. The bending moment is the bending effect that occurs when external force is applied to the structure element. Our objective is to measure the bending moment of material when subject to different load at different distance. So I will pass the presentation to the next presenter.
Assalamu alaikum warahmatullahi wabarakatuh. I'm Zakaria Muhammad. I'm going to present theory part and methodology part. For the theory part, bending moment is the product of force applying on the beam with the distance between the point of application of force and fixed end of the beam. Internal stresses and strains are created when a beam is loaded by a force or cables. Bending momentum shear force. If you look down these tables, to get the bending moment, you have to look down these tables and use all formulas given in this here. For the methodology part, this is the apparatus of the experiment. The apparatus of the for this experiment consists experimental beam, load, and load hangers. We use as a load we use 4 Newton, 6 Newton, 8 Newton, and 10 Newton. Here it is the procedures and steps for the experiment for table 1. If you look the step 1, it says the beam is set up where the low hanger B2 is 100 mm from B1 and B3 is 300 mm from B1. Then step 2, you have to align the two bars to adjust the spring balance. Step 3, the initial reading from the spring balance is recorded for 0 load column for all B1, B2, and B3. After that, you have to hang a 4 Newton weight on B1 and adjust the spring balance. After that, after you adjust the spring balance, you need to record the reading. Step 5, you have to repeat the step 4, but instead of using B1, you have to put the 4 Newton B2 and B3. After that, finally the whole procedures were repeated by using 6 Newton, 8 Newton, 10 Newton, and 12 Newton loads. Here it is the procedures and steps for part 2. So if you look down the part 2, step 1, it says the beam for part 2 was set up as shown as figure 2. If you look the figure 2, B1 is located is 150 mm far from the B2. B2 is fixed, and B3 is loaded 400 mm far from B2. Step 2, align. You have to align and adjust the spring balance. Step 3 is the spring balance of initial reading is recorded for zero load on all B1, B2, and B3. load hangers. Step 4, you have to hang 4 Newton weight on B1, 6 Newton weight on B2, and 8 Newton weight on B3. And then after that, after you hang, you have to adjust the spring balance and record the reading. Step 5, B2 is 200 millimeter from B1, and B3 is adjusted to be 500 mm from B2 as shown figure 2. If you look figure 3, we bought load hanger B2 200 mm from B1 and B3 500 mm from B2. Last step is you have to apply 4 Newton load at B1, 6 Newton on B2, and 8 Newton at B3, and adjust the spring balance and record the reading. That's all for me and for the methodology part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good morning. So my name is Hisham. So today I will present a part which is result. So for data part 1, so we are using 4, 6, 8, 10 and 12 Newton for the load, and for distance we are using at P1 is 200 mm from point A, while at P3 is 400 mm from point A. So these are the data. So for data part 2, so we are using the distance, two different distance, which is at P1 150 mm from point A, and at P3 700 mm from point A, and the other one at P1 equal to 50 mm from point A, and at P3 800 from point A. So the fixed load that we are using for data part 2 is 4, 6 and 8 Newton. So these are the data. So sample calculation for part 1. So the sample load is equal to 4 Newton. So these are the distance that we are using for part 1. So the calculation to find bending moment, the equation is net force times 150 millimeters. So we can get 600 Newton millimeter here. So to calculate the theoretical value of bending moment, so first we need to find RA. So the equation is RA times the total distance, which is 900 millimeter, equal to net force times the distance from P1 to RB. So equal to 4 times 700. So we can get 3.11 Newton. So to calculate the theoretical value of bending moment, we use the equation. We just enter the value of RA into the equation. So we can get the value of theoretical value of bending moment. Next, it's also same for P2 and P3. So for the bending moment, we just net force times 150 millimeters, and for the theoretical value of bending moment, we just change the distance and the net force. So for P2, we get 10 Newton for the net force, and for the distance is the distance between P2 to RB. So, and then we just enter the value of RA into the equation. So we get 2000 Newton millimeter. It goes the same for P3. We just change the distance and the net force for P3. So for P3 is 400 from RB. So we just change and we get RA, and then we enter the value, and then we get 533 Newton millimeter. So for the sample calculation for part 2, so this is for distance P1 equal to 150 millimeter from point A, and P3 equal to 700 from point A. So the bending moment equation is also almost the same. where we can get from net force times 150 mm. And then for theoretical value of bending moment, we need to find RA, where RA times the total distance, which is 900 mm, is equal to distance P1 to RB plus P2 times distance P2 to RB, which is 600, and plus P3 times the distance P3 to RB, 200, and we get RA. And then we just enter the value of RA times 300, which is P2 to RA, and minus P1 times 150, we can get the Newton millimeter. And then the same goes to the next distance for 50 millimeter and 50 millimeter at P1 and 800 millimeter at P3 from point A. So we just change the distance, we can get the RA, and also we can get the theoretical value of bending moment. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nurishira binti Ibrahim. I will present about the discussion. So for 1, when the load was double in part 1 of experiment, did the bending moment double? Explain your answer. So the answer is, load increase, the bending moment increase. So when the stress is being double, the bending moment will be double too. For example, when P1 equal to 4N, the experimental value of bending moment is 600, while the theoretical value is 533. When P1 is X Newton, the experimental value is 1200, while the theoretical value is 1067. As it is double, the value shall be 1067, but it produces 1200, with different value of 133. The table shows the difference of value of bending moment when the load was increased. That is the table. Second, compare the average figure for each of the experiment by using the bending moment value obtained from the experimental and theoretical. As we know, percentage error is equal to experimental value minus theoretical value, that is always positive, divided by theoretical value times 100. So for the part 1, the table is the for part 1, there is a different load, 4 Newton and X Newton. So for the percentage error at P1 at N 4 Newton is 12.57%, at P2 is 25%, and at P3 is 12.57%. For X Newton, for P1 is 11.52%, P2 25%, P3 12.5%. So then, we calculate the average percentage error for 4N and XN. So 4N, we get is 16.71%, and for XN is 16.34%. So the table is for part 2. There is a different distance. For distance P1 equal to 150 and P3 equal to 700, the percentage error is 25%, while at P1 equal to 50 and P3 equal to 800, the percentage error that we got is 12.43%. Next, the average percentage error value for both 4N and XN load are quite significant, in which this may due to some errors that encountered during the experiment was carried out. For load in part 1, the experimental value of bending moment is close, while the theoretical value, thus the bending moment is proved to be true. The possible error in this experiment are instrumental error, that is, the scale of the spring balance is not precise enough to get the accurate value. Second, random error, that is, the hanger might be moving during the adjustment for beam was made. And last one is parallax error, that is, the eyes of the observer not perpendicular to the scale. So for the pre-question in this experiment, we must use a more precise spring balance. Second, the position of hanger must be correction every time during the adjustment. And last one, make sure the eyes of observer must perpendicular to the scale when take the reading of measurement. So I will pass this presentation to next presenter.
Assalamu alaikum everyone, and hello. I am Blaise bin Mahdi, and I'm gonna present to you our conclusions from the bending moment experiment. So the forces set down by the loads and the perpendicular distance are both directly proportional with the bending moment. For example, when the load is increased, the bending moment will increase. And the experimental findings in the experiment that we conducted proved that the principle of bending moment and demonstrated that the principle of the bending moment can be used to calculate the bending moment. As a result, the hypothesis and the theories were proven correct. Some errors that might occur during the experiment are the hangers might move during the realignment of the beam. When taking the readings of the spring load balance, you have to take from an IDV level for a more accurate reading, and the scale of the spring balance might not be accurate, which will affect the results. To make sure not to fall into these errors, always make sure to adjust the spring balance after each reading, and also adjust the hangers after each reading to avoid errors, and try to take the reading of the spring balance from an eye level for a more accurate recording.